All right, so now we're moving on to chapter 8, and this is the first section. We're going to break this section up into two videos. So this is section 8.1, and what this section is going to focus on is the Pythagorean theorem. All right, so in video 1, we're going to use the Pythagorean theorem, and video 2, we're going to use its converse. All right, so we're going to break this up into two separate videos. So video 1 and video 2. All right, for this video, what we're going to do is our essential understanding. So what I want to make sure that you guys know at the end of this video is to be able to use the Pythagorean theorem to solve for a missing side, so to find a third side of a right triangle. All right, we've already done questions with Pythagorean theorem before, so this really is not anything new. But we will learn about a few different new things, and also how we can use the Pythagorean theorem to determine what type of triangle we have as far as acute, obtuse, or right. All right, so the Pythagorean theorem, we know that it is our two legs squared added together is equal to this to our hypotenuse squared as well. Now we will go through a question in class in which I'm going to have you guys try and prove this on your own, but we know a squared plus b squared is equal to c squared. All right, that's the formula that we've used throughout this year already, so it's really not anything new. And in order to use Pythagorean theorem, you have to have two of the three sides. So you need to have two, either one leg and the hypotenuse, or both legs. Now, something new, a Pythagorean triple. So if we say we have a Pythagorean triple, that means that the three sides of the triangles, or the three numbers that we have, satisfy a squared plus b squared is equal to c squared. So it satisfies the Pythagorean theorem, and it's also all whole numbers. All right, so a Pythagorean triple are three whole numbers that satisfy the Pythagorean theorem. All right, so we're going to go through a couple examples with this. So find the length of the hypotenuse and explain, do they form a Pythagorean triple? All right, so that's what we're going to do now. We're going to find the missing side, and then we're going to determine if the three sides form a Pythagorean triple. So since this is a right triangle, I know that we can use a squared plus b squared is equal to c squared. Now, the only letter that matters that you substitute in for is c, and c must be our hypotenuse. All right, so a and b are interchangeable, but the hypotenuse must be your c. And then we substitute, doesn't matter, it's 20 or 21, so it's 20 squared plus 21 squared. We substitute, doesn't matter which one for a or b, is then equal to c squared. 20 squared is 400. Let me just fix this. And 21 squared is 441, is then equal to c squared. Now remember, same thing as before. We know that this has to be the positive number, but I want you guys to not get into bad habits. So when you guys are solving this, I do want to see you put plus or minus when we're solving for c. So then we know 841 is equal to c squared. So then to solve for this, we have to take the square root of each side. So c is then equal to plus or minus 29. And then since we can't have a negative number, we would reject a negative number, and c would just be equal to 29. So I do want to see you guys, if you look at the examples in the book, they won't do this step where it's plus or minus, because we know it has to be the non-negative side since we're talking about the side of a triangle. But when you guys do this, I don't want you getting in bad habits. So when you're doing this work, I do want to see these two steps are important. All right, you'll lose points in your test if you don't show that. And now we know that this is equal to 29. So since 20, 21, and 29 satisfy the Pythagorean theorem, a squared plus b squared is equal to c squared, and they're whole numbers, then yes, they do form a Pythagorean triple. So yes, they do form a Pythagorean triple. All right, and then this video just has one more question that we're going to go through. And now it's just solving for the missing term, so solving for x. So it says, what is the value of x? But this one does ask for us to write it in simplest radical form. All right, so there might be times where you're asked to round to the nearest tenth. There might be times where you're asked to keep it in simple radical form. So just make sure you're reading the directions and following what is being asked of you for each particular question. So for this one, we know it's a right triangle. So since we have a missing side, we can use a squared plus b squared is equal to c squared. Remember, the only one that matters that you fill in for is c, so that has to be our hypotenuse. So 20 has to go in for c. X and 8 can go in either one, a or b. It really doesn't matter. So we'll have x squared plus 8 squared is equal to 20 squared. So x squared plus 64 is equal to 400. Subtract 64 from both sides. So then x squared is equal to 336. Take the square root of each side. So x is equal to plus or minus the square root of 336. So we're going to do this step first and just reject the negative. So we know x is equal to the square root of 336. Now, it asks you to write it in simplest radical form. So we need to simplify this. So we're looking for perfect squares that divide evenly into 336. So 16 goes into 336 21 times. So we can rewrite 336 as 16 times 21. And then the square root of 16 is 4. So this in simple radical form is 4 times the square root of 21. All right, and that is it. That's your final answer for this. And that's the last question on this video.